So starting with the first problem, which is problem 16-120, in which we have a rigid body mechanism being shown to us, and we need to find out if the piston is moving towards the right with the velocity and acceleration shown to you, that is, it is moving towards the right with a speed of 5 feet per second and an acceleration of 3 feet per second square. We need to determine the acceleration of point A, the linear acceleration of point A, which is constrained to move within the curved path having a radius of 1.5 feet. So in order to perform the acceleration analysis, or in order to determine the acceleration of point A, first of all, since omega is not known to us, so we need to first of all find out this omega, that is omega of this rod AB. In order to perform the velocity analysis first, can you tell me what should be the value of VB vector? We are using the conventional XY coordinate system. Since the piston is moving towards the right, so point B or piston B would be moving with a speed of 5 feet per second. That is, the vector form of VB is going to be 5I. What about the motion of link AB? Is it rotation or general plane motion?
General plane motion.
So it is general plane motion. Probably, अगर हम इस motion को गौर से देखें तो at the very next instant, point A would be located at this point, जो कि मैंने black color से cross बनाया है. Similarly, point B would be located at this point. So if I draw this link AB at the very next instant, it would be in probably this location. So it has undergone simultaneous translation as well as rotation. It means that this link AB would be in general plane motion. So applying the general plane equation on this link AB, taking point B as our base point, the equation would become VA to be equal to VB plus omega cross R, where omega is going to be the angular velocity of this link AB and R is going to be the relative position of A with respect to B. So this is the relative velocity equation. In this equation, VB, as we have written in step number 1, it is going to be 5I plus omega cross R. If we take a look at these instants, this rigid link is basically rotating in this direction, which is counterclockwise direction. So we can write omega to be equal to omega ABK cross RAB, the relative position of A with respect to B. So basically we are talking about the vector which is starting from point B towards point A. So since this vector lies in the second quadrant, so it should have negative x and positive y. The total magnitude of this vector is 2 units and the angle is given to you as 30 degrees. So we can write it as minus 2 cos of 30i plus 2 sine 30j. So this is going to be the vector form of RAB. Okay, so once you take this cross product, it would become 5i plus omega ABK cross minus 1.732 I plus j. So this is going to be this vector. Again, after taking this cross product, it is 5i. If we are using that smaller circle ijk, so we can write minus 1.732 omega AB and k cross I is j. So this first term would be j. Similarly, the second term would be omega AB and k cross j is minus I. So we are going to put it as minus I. So let us say that this is our equation number 1. I hope that this cross product is clear to all of you. Okay, what about the left hand side of this equation? It represents the absolute velocity of point A. Now, since point A is constrained to move within a circular slot having a radius of 1.5 foot, so whenever a particle or a rigid body is moving in a circular path, what should be the direction of velocity? Tangent to the circle. So for this instant, what is the line which is tangent to the circle at this instant? The vertical axis. Okay, so if the piston is moving towards the right, what should be the velocity of point A? Down the y-axis or upward? Down the y-axis. So can we write VA to be equal to minus VAJ?
Yes.
Okay, so putting the value of VA vector to be equal to minus VAJ and then comparing the I and J coefficients on both sides of this equation. So once we compare the I coefficients, we are going to get 0 equal to 5 minus omega AB. Once we compare the J coefficients, we are going to get minus VA to be equal to minus 1.732 omega AB. So solving these two equations would give us the value of omega to be equal to 5 radians per second. And since this value comes out to be a positive quantity, it means that our assumed direction of omega is correct. Similarly, the value of VB comes out to be 8.66 feet per second. And again, since it comes out to be a positive quantity, it means that our assumed direction of VA is correct, that is downward. I hope that this velocity analysis is clear to all of you. एक तरह से revision है आपके quiz number 9 की.
Yes.
Okay, now moving on to the acceleration analysis. In order to perform the acceleration analysis, it is given to us that this piston A is moving towards the right with an acceleration of 3 feet per second square. So again, starting from that piston, the acceleration of point B is given to us as 3I feet per second square. And since link AB is in general plane motion, so we are going to write the relative velocity equation for this link AB, taking B as our base point. So that equation would become AA, which is the absolute acceleration of A, should be equal to AB, which is the absolute acceleration of B, plus alpha cross R minus omega square R, where alpha is going to be the angular acceleration of this link AB, omega is going to be the angular velocity of this link AB, and R is going to be the relative position of A with respect to B. So these are the vectors जो कि हमने लिखने होंगे. As we know that AB is basically equal to 3I plus alpha cross R. Again, alpha is assumed to be in a counterclockwise direction, so we can write this alpha as alpha ABK cross RAB. RAB हमने already निकाला है पिछले step में, which is minus 1.732I plus J. So this was our RAB minus omega square. Omega अभी again हमने last step में निकाल लिया था, which was 5. So 5 square into minus 1.732I plus J. So this is going to be our right hand side of this equation. Again, we are going to use the smaller triangle method, smaller circle method for finding the cross product. So once we solve or once we evaluate this cross product, the right hand side of this equation would be of the form, अगर मैं उसको simplify करके लिख दूँ, it should come out to be 46.3 minus alpha AB I minus 1.732 alpha AB plus 25 J. So this is going to be the right hand side, whereas the left hand side represents the absolute acceleration of point A. So let's say that this is our equation number 1. Okay, now as far as the acceleration of point A is concerned, since point A is constrained to move in a circular path, so the acceleration of point A would comprise of two components. The first one is the tangential component of acceleration, which is AAT. The second one is the normal component of acceleration, which is AAN, and the total acceleration is going to be the vector sum of tangential and normal components. I hope कि ये चीज याद है आपको chapter number 12 की.
Yes.
Okay, so what about the normal component of acceleration? What should be its magnitude? अगर मैं AAN की बात करूं, the normal component would have a magnitude of, बता सकते हैं?
सेंटीमीटर टाइप निकालो.
जी, तो क्या था वो? कुछ chapter 12 को रिवाइज करें, रिफ्रेश करें.
स्क्वायर ओवर आर.
So the normal component would have a magnitude of v square over rho या v square over r. What about v? कौन सा v होगा ये?
ये वो वाली
tangential velocity होगा,
जो ऑलरेडी हमने स्टेप नंबर 1 में फाइंड आउट किए, which is the velocity va. That velocity was, if you remember, अभी हमने पिछला स्टेप किया था, that was 8.66 feet per second. So basically this VA was 8.66 feet per second. What about raw? ये radius क्या है जिसपे A जो है वो move कर रहे हैं?
2 feet.
जरा गौर से देखें.
सर 1.5 feet.
चलें मैं आपसे एक और कहता हूँ, अभी हम सवाल को तो कंटिन्यू रखेंगे ही. What about कि मैं ये जो कार्डबोर्ड जिसमें स्लॉट बना हुआ है इसको रिमूव कर दूं और इस कार्डबोर्ड को मैं रिप्लेस कर दूं एक रिजिड लिंक से जो कि पॉइंट डी कह लें, इससे ग्राउंड हुआ है. कार्डबोर्ड हटा दूं और उसको इस लिंक से जो है वो रिप्लेस कर दूं. अभी भी रोटेशन ऐसी होगी पॉइंट ए की.
यस सर.
ठीक है, तो इट मींस के आपके पास जो पॉइंट ए है वो एक तरह से रोटेट कर रहा है इन अ सर्कल हैविंग अ रेडियस ऑफ 1.5 फुट. अब यहाँ अक्सर स्टूडेंट गड़बड़ क्या करते हैं कि इस 2 फीट से इसको कंफ्यूज करते हैं. नहीं, 2 फीट तो लिंक ए भी जनरल प्लेन मोशन करे, लेकिन पॉइंट ए जो है इट इज इन प्योर रोटेशन with respect to point D, which is at a distance of 1.5 meters from point A. In other words, अगर मैं इस कार्डबोर्ड की जगह ये एक रेड कलर का रिजिड लिंक लगा दूं having a length of 1.5 feet, तो वो लिंक जो है वो प्योर रोटेशन में है about point D. Is this point clear to all of you?
Yes sir.
It means that in this AN, V तो हमारे पास आ गया which is 8.66. जो रॉ की वैल्यू होगी that should be equal to 1.5 feet. Is this point clear to all of you?
Yes.
Okay, the magnitude of AN is V square over rho. What about its direction? As per our understanding, normal component किस तरफ होता है?
Towards the center.
Perpendicular.
Towards the center होता है. So towards the center आपकी कौन सी एक्सिस बन रही है यहाँ?
AB.
एक्सिस कौन सी है टुवर्ड्स द सेंटर ऑफ दैट सर्कल?
AB.
नहीं. एनी अदर करेक्ट आंसर?
हॉरिजॉन्टल एक्सिस.
हॉरिजॉन्टल एक्सिस. तो आप यूनिट वेक्टर i के साथ इसको रिप्लेस कर सकते हैं. सो द ओवरऑल AN वेक्टर वुड बिकम V square over rho I. Is this point clear to all of you?
Yes.
So this would comes out to be 50i because V square over rho is 50. So AN would be equal to 50i. Similarly, if we talk about the tangential component of acceleration, which is AAT, although you don't know its magnitude, उसका magnitude unknown है, आप उसको AAT के तौर पे ही रखेंगे. But what about the direction of tangential component of acceleration? किस direction में होता है AAT?
वर्टिकल होगा क्योंकि टेंजेंट टू सर्कल है.
As the name indicates, since it represents the tangential component, so it should be basically tangent to that circle, tangent to that curve at that instant. So at that instant, tangent to the curve is your vertical axis. So what should be AAT vector? It should be minus AATJ, isn't it?
Yes, sir.
So overall, this vector AA would become 50i minus AATJ. Clear है ये चीज?
Yes.
So replacing this AA as 50i minus AATJ and then comparing the I and J coefficients on both sides of this equation number 1. If you compare the I coefficients, it means that 50 should be equal to 46.3 minus alpha AB. Once you compare the J coefficients, it means that minus AAT should be equal to minus 1.732 alpha plus 25. So once you solve it, alpha AB comes out to be minus 3.70 radians per second square. The negative sign indicates that the assumed direction of alpha is going to be reversed. That is, alpha is acting in a clockwise direction. Solving for the other unknown, which is AAT, will give you the value of AAT to be equal to 18.59 feet per second square. And since it comes out to be a positive quantity, it means that the direction of tangential component is basically in line with the direction of velocity. Is this point clear to all of you?
Yes.
So once you have found AN and AAT, then the overall acceleration would have a magnitude of AAT square plus AN square whole under root, which comes out to be 53.34 feet per second square. क्लियर है? कोई क्यूरी वेलोसिटी एक्सेलरेशन के हवाले से जो आप पूछना चाहें?
सर ये ओमेगा स्क्वायर आर है, इसमें ओमेगा स्केलर है, सिर्फ मैग्नीट्यूड पुट करेंगे?
जी, सिर्फ ओमेगा का मैग्नीट्यूड पुट करना है। ये जो हमारे पास ये फॉर्म है अल्फा क्रॉस आर माइनस ओमेगा स्क्वायर आर, इसमें बाकी सब चीजें वेक्टर हैं, सिर्फ ये जो ओमेगा है इट इज स्केलर मैग्नीट्यूड ऑफ ओमेगा। अगर आप चाहें ओमेगा को भी वेक्टर फॉर्म में पुट करना चाहते हैं तो देन यू आर गोइंग टू यूज द फॉर्मूला अल्फा क्रॉस आर प्लस ओमेगा क्रॉस आर। अब इस सूरत में अगर आप ओमेगा डालना चाहते हैं तो वो वेक्टर फॉर्म में डालेंगे, डबल क्रॉस प्रोडक्ट ले लेंगे, लेकिन इन द एंड ये नतीजा आपका यही निकलेगा जो माइनस ओमेगा स्क्वायर आर के बराबर है। तो वहां अपना टाइम जाया करने के बजाय डायरेक्टली यू कैन यूज द स्केलर वैल्यू ऑफ ओमेगा।
इसके में सर साइन को देखेंगे कि नहीं, अगर प्रीवियस वैल्यू इसकी नेगेटिव में हो तो नेगेटिव पुट करेंगे।
कौन से साइन को? देखिए स्केलर वैल्यू है, ये सिर्फ स्केलर मैग्नीट्यूड है, स्क्वायर है ओमेगा स्क्वायर, तो साइन से कोई फर्क नहीं पड़ेगा।
ओके सर, थैंक यू सो मच।
Okay, any other thing which you want to ask regarding problem 16-120?